Hi guys, and welcome back. Still Mr. G here. Let's look into question 2 of this 2015 final exam. Okay, so here another easy one that they start you with, simplify. Okay, we've got to pay attention to that. We're not solving for x or factorizing in any way. So this here is going to be, well, I see that I need to write everything as a prime base. So this is a prime base already. I'm not really going to bother and simplify that. In any case, I'm going to simplify 4 and 2. So 4 as a prime base is 2 squared. So I'm going to multiply right away there by that exponent. And then the same thing down here, 8 is 2 to the exponent 3. So I'm going to have here 2 to the exponent 3 and minus 3. Then, of course, I just take in what the denominator up there to the numerator. So I have to take note that each exponent here will change a sign. So this is 2n plus 2. And I might as well just add up everything. Plus 2n plus 2 minus 3n plus 3. And so you can see n and n is 3, and they will take care of that. And then here I'm going to have 4 plus 3, which is 7. So I'm going to have 2 to the exponent 7. And then you can, of course, punch that in your calculator. You get 128. Nice and easy routine. Here, guys, you've got to, again, show your caliber here in terms of the laws of sets. In exponents, you know, we were basically asked in 2.1.1 to show if we are aware that x squared plus 3 is just the same as x squared times x to the exponent 3. So we're doing the reverse of law 1. Here again is the same thing. We're supposed to do the reverse of this law of sets. If you got square root of ab, it is square root of a times square root of b. And if you look at this whole thing here, you can regard it as your a. That whole thing there, you regard it as your b. And you can see now we're all gonna work nice and easy and have x, okay, plus square root of 2x minus 1 into, so this should be a bit long, x minus square root of 2x minus 1. Okay, now again, guys, you are aware that x squared minus y squared is difference of two squares, and this factors into x minus x minus y into x plus y. But if you look at this, this is exactly what you have there. Like, it's like 2x minus 1 is your y. So you literally have difference of two squares here. So I'm not even going to bother and multiply this stuff out. I know I'm going to have my square root, but I'm just going to have x squared. And if I multiply this and this, the square roots take care of each other. So I'm going to have minus, then I'm going to have 2x minus 1. That's it. And then, of course, this simplifies to x squared minus 2x plus 1. But guess what? This is a square trinomial, meaning it factorizes as x minus 1 into x minus 1, and it is basically x minus 1 all squared, okay? And so the square root here takes care of that exponent. So my final answer is x minus 1. Really basic procedure, guys, just that you had to work backwards instead of forward as you usually do. All right, here 2.2 given p is that. For what values of x will this thing be a real number? So first of all, whenever we have square roots, we know for us to have real numbers, we want whatever is inside the square root to be positive. That's it, for us to stick to the set of real numbers, okay? Now, for this thing to be positive, then my denominator should also be positive, because I don't want to divide by a negative number, okay? Or you can say, another way to look at it is you don't want to divide by 0 for this thing to be defined. So therefore, guys, x should be greater than minus 2. And that's really your answer. I'm not going to really insult your intelligence by doing 2.2.2 for you, because it is a matter of substitution. You just have to take this value, plug it in that whole thing, and I think your answer there should be 2, okay? it should be, yeah, I think it should be 2 if you put that, because that's going to be 1 plus 2 plus what? Plus 1. Yeah, 1 plus 1 is going to be 2. So yeah, that's pretty good. All good. So let's look at this one. Calculate the sum of the digits of 2 to the exponent of 2015 times 5 to the exponent of 2019. Guys, these are type of Maths Olympiad questions. So really, for you to cope at this point, if you don't do Maths Olympiad, this will be a knock on you. But of course, glad you have tuned in to revise and get a hang around this. So let's think about this. If I have the product 3 times 6, what is 3 times 6? It is 18. So what is the sum of these digits? It is 1 plus 8, which is equal to 9. Okay, so what they're really saying is, okay, guys, try and find out the product of this. In other words, multiply these two numbers, get the answer. Then after getting the answer, add those digits together. So that's what we're going to do. And of course, the calculator will really die from performing this large product, okay, from computing this. So let's help the calculator a little bit here by using our laws of exponents. So first thing I'm going to do here is to see if I can write these things in terms of the same exponents, and that's one thing that I first realized. And then, of course, this simplifies to that times 5 to the exponent of 2015 times 5 to the exponent of 4. Now I group this together. This is 2 times 5 to the exponent of what? 2015. And you are wondering, wait a minute, what did you just do? And I'm just going to remind you kindly here that if you've got AB to the power of n, this is a to the power of n times b to the power of n. So when the exponents are the same, you can actually multiply the bases and raise them to that same exponent. So you again know how to move from left to right. Question is, do you realize you can now move from left to right? So don't memorize mathematics. Don't be stereotyped when doing mathematics. That's the key lesson there. So I've got 5 to the exponent 4 here. And what is this thing here? 2 times 5 is actually 10 to the exponent of 2015. What is 5 to the exponent 4? It is, I think, 625. Yes, that's it. Now, let's quickly have a look at powers of 10 or exponents of 10. 10 to the exponent 1 is 10. And then 10 to the exponent 2 is 100. 10 to the exponent 3 is 1,000. So what is 10 to the exponent 4? I'm sure you can tell it will be, we just keep on adding a 0 each time. So it doesn't matter what number you raise 10 to, you will always have 1 and so many zeros, probably like n times. So that is the basic idea here. We're going to have 1, 0, 0, 0, 0, and so many zeros times 625. Okay, and what is, now let's check, what is 10 times 4? This is 40. What is 100 times 5? This is 500. What is 100 times 25? This should be 2,500. You see multiples of 10, I just need to multiply by that, then I just put the zeros that are there. So that's essentially what I'm gonna do here, 625, then 0, 0, 0, and I know there's just gonna be so many zeros. So what is this? This is the product. In other words, this thing here is going to multiply to something of this nature, 625 and number of zeros. But I don't really care about how many zeros it is because I need a sum, the sum here. So the sum is just going to be 6 plus 2 plus 5 plus the many zeros, okay? And we know zeros do not really make a difference. So this thing here is going to be a 13. And that's really the final answer for this, the sum of the digits. Okay, guys. Yeah, as I said, it's a question that's usually there, one of those Math Olympiad and stuff. So I hope you have learned something, you have taken note out of this. There are other ones that come like find a factor of this, or what is the largest exponent k such that this thing is a factor. You will get those. It will be just one of those questions. Don't be hard on yourself. It just requires you to think a little bit outside the box. Okay, I hope you have enjoyed watching. Keep watching. I'll catch you later.